So open up your notes to page 9 and we will finish out rhombuses. All right, so number 6 says the diagonals of a rhombus are 18 meters and 80 meters long. So the very first thing I'm going to do is draw those two diagonals. What do the diagonals of a rhombus do to each other? Yes. The diagonals bisect each other. So when I draw these two diagonals, I want to draw them so that they are cutting each other in half. Kind of like this. And then I'm going to draw the outside of the shape around those diagonals. So I'm going to go from point to point around my shape. So it should look something like this at the end. You said the diagonals are bisecting each other, so that means these two halves are congruent, and these two halves are congruent. What do we know about all four sides in a rhombus? They are congruent. A rhombus has 4 congruent sides. So this side here is congruent to this side over here, is congruent to this side here, is congruent to this side here. All 4 sides. The diagonals are splitting each other in half, but then similar to a square, all 4 of the outside sides are the same size. And what is happening right here in the center where the diagonals are crossing each other? Yes, it intersects at a right angle. So the diagonals bisect each other and are perpendicular. Okay. These diagonals are 18 meters and 80 meters long, and you told me that the diagonals are bisecting each other. And bisect means what? To cut in half. So if this shorter diagonal right here is the one that is 18 meters, and it's being cut in half, how big is each half? 9. So the top part here is 9. The bottom part here is 9. The other diagonal is 80 meters long, so that would be this one. How big is each half of that? 40. 40 and 40. They want us to find the perimeter of the rhombus. How would you find the perimeter? Add all the sides. So we need to figure out how big the sides are. So I want to look carefully. I don't know how big any of the sides are. Scoot this down just a little bit. Hold on just a second. There we go. That's what I wanted, because I want to scoot this whole thing down just a little. There, finally got it down. We need one of the sides of the rhombus, because if I can find how big one side is, what do I know about the other 3 sides?
They're all the same.
They're all the same. So if I can find one, I'm good. I want you to look carefully at 1/4 of this rhombus. Just this little piece right here. What kind of a shape did I just highlight?
Triangle.
A triangle. It's not isosceles. Isosceles triangles have 2 congruent sides, and I don't have 2 congruent sides here. But what kind of special triangle is this?
It's a right triangle.
It's a right triangle. How many sides of this right triangle do we know? We know 2 sides. We know one side is 9.
Oh, yeah.
And we know the other side is 40. We are going to do Pythagorean theorem. So let's do a squared plus b squared equals c squared. What part of the triangle does c have to be?
Hypotenuse.
The hypotenuse. How big is the hypotenuse of this little yellow triangle? We don't know, so that has to stay c. So I still have c squared over there. So what goes in for a and for b? 9 squared and 40 squared. So I have 9 squared in the place of a squared and 40 squared in place of b squared. What is 9 squared? 81. Plus, what is 40 squared?
200.
Nope.
Wait, I mean 2.
40 squared. What does it mean to square something?
Multiply something by itself.
Multiply it by itself. So we need to do 40 times another 40.
1600.
1600. 1600. So then we add 81 and 1600 together. That gives me 1681 is equal to c squared. What do I need to do now? Square root. And if you do it to one side, have to do it to the other side. So over on the right, the squared and the square root cancel each other out, which means I have just what? C. And what is the square root of 1681? 41. It actually came out to be a nice whole number. So this side over here is 41. So how big is this side? 41. And this side down here? 41. And this side over here? 41. So how would we find the perimeter then? Yep. We're going to add all the sides together. So I could add 41 a bunch of times. Or what could I do to shortcut that? 41 times 4. We get 164. Should we put units with that? What units? Meters. Beautiful. All right. So with that problem right there, we have now wrapped up our discussion of rhombuses. A good chunk of your homework is dealing with rhombuses. It's rhombuses and squares. So we talked on Friday about rhombuses. We talked today a little bit about rhombuses, and now we're going to switch our attention over to squares. So squares are really interesting. A square is a parallelogram with 4 right angles and 4 congruent sides. What other shape have we talked about that has 4 right angles? Rectangles. What other shape have we talked about that has 4 congruent sides? A rhombus. We haven't talked about squares yet. I said what other shape that we've talked about has 4 congruent sides. So a square is a parallelogram that is also a rectangle and is also a rhombus. A square is both a rectangle and a rhombus. So let's talk about the properties of a square. It's going to have all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. When I think about the sides, we mentioned something up here about the sides. What do we know about the sides of a square? They're all equal. So all four sides are congruent. And what else do we know about the sides? Not just of a square, but of a rectangle, rhombus, parallelogram, because it has all of those features. That's when I get to angles, but yes, we will write that down. Let me go ahead and add that. We will have 4 right angles. Right. But I want to jump back to the sides for just a minute. All 4 sides are congruent and parallel, and both pairs of opposite sides are parallel. So I'm going to go look at my picture now. We have 4 congruent sides, so I'm going to put 1 tick mark on each of the sides. And then the left and the right are parallel. The top and the bottom are parallel. Beautiful. Let's talk about diagonals next. What do we know about the diagonals of a rectangle? They bisect each other. That's going to be true whether it's a rectangle or a rhombus, because that's true for all of my parallelograms. They bisect each other. What else do we know about the diagonals of either a rectangle or a rhombus? In a rectangle, they're congruent, so here they would also be congruent. What about with a rhombus? What happens where the diagonals cross each other? Makes a right angle, so they are congruent and perpendicular, and they bisect each other. So I'm going to draw in my diagonals on this square here to the right. So we're going to draw a line between opposite corners. Because my diagonals are congruent and they bisect each other, that means that all 4 of those little half diagonals are congruent. And where they meet in the center is a right angle. A square, just like a rectangle, has 4 right angles, and the angles are bisected by the diagonals. So I'm going to draw my 4 right angles in the corners of my square. And then we said those angles are being bisected by the diagonals. What does bisect mean? Cut in half. How big are the corners on a square? The corners on a square are 90 degrees, and they're being bisected. Yes. So they're 45 degrees. All these 45-degree angles. Each of the corners is made up of 2 45-degree angles put together, being divided by that diagonal. I want you guys to look at 1/4 of the square right here. I've just highlighted it in yellow. What kind of a triangle is that? Yes, it's isosceles. What else? It's not just isosceles. It's a 45, 45, 90. So this is an isosceles right triangle, or a 45, 45, 90 triangle. So we get a 45, 45, 90 triangle when we take a square and we split it in half. And we get 4 45, 45, 90 triangles if I take a square and I cut it in half in both directions. If I draw in both diagonals, splitting this into 4 little triangles, I end up with 4 45, 45, 90 triangles. But also if I just look at half the square, that is also a 45, 45, 90 triangle. This here is also a 45, 45, 90. All right. Let's see if we can use this information to answer a couple questions about squares. We got 3 questions about squares that we're going to answer. Number 8 says that EFGH is a square. And then it says that FJ is 19. So from F to J, this segment right here is 19. What do we know about the 4 sides of a square? They are congruent. So all 4 of these sides on the outside are congruent. What do we know about the diagonals of a square? They bisect each other. What else? They're congruent and they're not parallel. The diagonals are not parallel. Perpendicular. There we go. So the diagonals are congruent and cutting each other in half. That means all 4 of these little segments are the same size. And it's forming a right angle where they cross. Well, if FJ is 19, and I want the length of FH, how many segments the size of FJ fit in FH? 2. 2 times FJ equals FH. How big was FJ? 19. So 2 times 19 equals FH. 38 is equal to FH. Nicely done. Could we have done that problem if they said that this was a rectangle instead of a square? Yes, we could have. Because in a rectangle, the diagonals are congruent and perpendicular. And they bisect each other. Sorry, in a rectangle, they're not perpendicular. In a rhombus, they're perpendicular. In a rectangle, the diagonals are congruent and bisect each other. And here, I was looking for that whole diagonal. So all I needed to use here was that the diagonals are bisecting each other. So this would have worked even if they had said this was a rhombus. We could have solved this problem even if they'd said this was a parallelogram. It didn't have to be a square in order for us to solve this. As long as the diagonals bisect each other, we can solve this particular problem. All right, let's go look at number 9. Number 9 says, in rhombus PQRS, PQ is 4x plus 3, QR is 41, and the measure of angle PQT is 2x plus 4y degrees. What must be the values of x and y so that PQRS is a square? All right, so PQ is 4x plus 3. And QR is 41. Says that the measure of angle PQT is 2x plus 4y degrees. So P over to Q down to T, this angle right here. Is 2x plus 4y degrees. That's really hard to see on the board. There, that's a little bit better. All right, so what do we know? Keep in mind, we want to force this to be a square. What do we know about the four sides of a square? They are congruent. They're all equal length. So I'm going to go ahead and mark that on my picture. All four sides are equal length. So what could I do to find x then? Absolutely. So we're going to take PQ. It is congruent to QR. So the length of PQ is equal to the length of QR. So you guys are absolutely correct. We're going to take 4x plus 3, and we're going to set that equal to 41. What would I need to do now if I'm wanting to get x all by itself? Subtract 3 from both sides. All right, so that would give me 4x equals 38. What now? Divide 38 by 4. And what do you get? 9.5. X equals 9.5. All right, we found one thing they wanted us to find. We now need to find the value for y. Well, I want you to look at this angle right up here. I know how many degrees that angle is, even though the problem didn't say so, because I want this to be a square. Talk to me about the full corner on a square. It's 90. So this corner up here, if it was the whole thing put together, would be 90 degrees. But I don't have the full 90 degrees. What's the diagonal doing to that 90-degree angle? It's splitting it in half, so it's 45 degrees, yes. So the measure of angle PQT is 45 degrees. And PQT is 2x plus 4y, so we have 2x plus 4y equals 45. I have an equation with two different variables in it. What can I do here?
You already know x.
Yes, we already know x. So what do we put in for x? So 2 times 9.5 plus 4y equals 45. What is 2 times 9.5? So 19 plus 4y equals 45. What do I do now? Subtract 19 from both sides. What is 45 minus 19? 26. So 4y equals 26. I'm going to bring that around here now. We're going to divide both sides by 4. Does 4 go evenly into 26? No. Does it come out as an okay decimal? Yes. What do you get? 6.5. Or you can leave that in fraction form as 13 over 2. All right. That brings us to our very last problem about squares. I have a square over here, ABCD. What do we know about all four corners on a square? They're 90 degrees. So I'm going to go ahead and put my 90-degree marks in the corners. What do I know about the four sides of a square? They're all equal. So how big is each side here then? 22. What are the diagonals doing to each other? They're cutting each other in half. And what else is true about those diagonals? They're congruent. So all four little pieces in here are congruent. What else is happening with those diagonals right where they meet in the center?
They're perpendicular.
They're perpendicular, so they're making a right angle right here. All right, let's see if we can answer these questions. The first thing we want is the measure of angle AEB. AEB, this angle right here. How big would that angle be? 90, yes. Okay. Next one is angle BAD. BAD. How big is angle BAD?
22.
Nope. Angle BAD.
Oh. I thought you said 80, so 90?
90. Yes. And then we have one more angle that we're looking for here. We want angle DCA. How big is angle DCA? Not 90. Look at how much I have marked. I have this angle right here marked. Is that a 90-degree angle? It's a 45. Thank you. It's a half of a 90-degree angle. It's that diagonal that's coming into the angle, splitting my 90 into two equal parts.
Oh, okay.
All right, we got 3 more parts to this question. Next thing they want to know is the length of AD. How big is AD? 22. Then we want EB. Well, this is EB. I want you guys to look carefully with me at this. Do you guys see that yellow triangle that I just highlighted? What kind of a triangle is that yellow triangle? It's an isosceles right triangle. What's another name for an isosceles right triangle? 45, 45, 90, yes. And we want a leg or the hypotenuse of that isosceles right triangle. What do I have highlighted in pink? Is that a leg or is that a hypotenuse of the yellow triangle? It's the leg. So I'm going to use hypotenuse equals leg times radical 2. You said we were looking for a leg, so EB is the leg. So I'm going to put EB in the place of L. How big is the hypotenuse? Yep, 22. So I have 22 equals EB times radical 2. What do I need to do to get EB all alone? Yep, we're going to divide both sides by radical 2. So that's going to cancel it out over on the right. Are we allowed to have a radical in the denominator? No, so we have to multiply top and bottom by radical 2 over radical 2. So up in the numerator, that would give me 22 radical 2. Down in the denominator, we would have radical 2 squared equals EB. What is the square root, or sorry, what is radical 2 squared? What is radical 2 squared? Is, yep. So it's just 2. That's absolutely correct. So I would have 22 radical 2 over 2 equals EB. Can I simplify 22 divided by 2? Yes, 11. So this would be 11 radical 2. 11 radical 2. All right. To do this last one, I'm going to redraw the square because I feel like I've got a lot going on in that picture over there. So I'm going to redraw this quickly. So we have A, B, C, D, and E right here. This time we want to look for DB, this right here. What kind of a triangle did I just highlight in yellow? It's another isosceles right triangle. It's another 45, 45, 90 triangle. We've got our 90 degrees right here at C. 45 and 45 in the corners of the square because those got cut in half. How big are all 4 sides of this square? 22. Looking at this yellow triangle, is that 22 a leg or a hypotenuse? Leg. Hypotenuse equals leg times radical 2. What's the hypotenuse of this yellow triangle? Not what is the size, what is it? Like which piece is the hypotenuse on this yellow triangle? DB. So I'm going to put DB in the place of the hypotenuse. How big is the leg? 22 times radical 2. So DB is 22 radical 2. So we used our special right triangle rules there with that. All right. That gets us to the end of squares. You guys have a homework assignment that is due tomorrow, right at the beginning of class. After we are done grading your homework, we will then talk about trapezoids. We have 2 types of shapes left to talk about, trapezoids and kites. We'll talk about trapezoids tomorrow. We'll finish up trapezoids and talk about kites on Thursday. And then Friday, we will grade your last homework of the module. The homework's due tomorrow, and then we'll talk about trapezoids.